Hello and welcome to another episode of Let's Make It. This is episode 55, recorded on the 17th of March 2014. And I have with me my cohort. How's it going, Bob?
It's going good.
So do you celebrate the 17th of March?
You know, I really didn't.
No green beer
today.
or okay.
No, didn't do any. I didn't go see the parade. It was just a regular work day for me, unfortunately.
Yeah, me too. I didn't really do anything. In fact, other than I got snow again.
I hate to tell you this, but it was shorts weather again today.
It was nice on the weekend. 60 degrees on Saturday, and today I got 5 inches of snow.
I had to put on pants this weekend. It was very disturbing.
So it's supposed to get nice and warm again tomorrow, and then by the end of the week back up in the 60s again. So I'm just going to deal with the temperature for a little while longer. I think we're getting close to being done with all the weather. So
yeah, I think you guys are ready for winter to be over this
oh,
year.
I'm more than ready for winter to be over. I have bees, and my bees didn't make it through the winter. But it was that bad of a winter. They So I think it's new bees. So that's waiting for spring for that to happen as well. So this week you're going to talk about a decade counter, and I'm going to go over the Galileo and some of the things that I'm figuring out about it, but there's some things that are not so great about it, maybe. I guess it depends on how you look at it. So we'll tackle the Galileo first before we get to your decade counter. Is that okay?
Okay.
All right. So I'm going to walk through a little bit like what the Galileo is. And it's right here. This is an Arduino. It's actually an Arduino. It's not an Arduino. It's Arduino compatible. They're they mention it everywhere. It's Arduino compatible. It's not an Arduino. It's made by Intel, and it's a lot bigger than a regular Arduino. Actually, do I have one? I have one right here. Grab it. This is an Arduino Uno, so you can see how much bigger it is. One of the things you're going to notice, this big plug is Ethernet, so it has Ethernet built into it, so you no longer need an Ethernet shield. That's one good thing. It has the same pin layout right here as what the Uno does. It follows the 1 or 1.1 pin layout of the Arduino, but it's actually running an Intel chip. It has a lot more RAM. It's a lot faster, and it has 2 USB ports. It has the one you connect to the computer to talk to it, and you have the one that it can interface to the computer and act like it's, you know, like a keyboard or whatever. So far you're not hearing anything negative about this. Like I said, it's considerably faster. One of the things that it does require external power. It cannot run off of USB power, so you have to have the power plug plugged into it. So that's something that's a little bit different. On the bottom side of it, they actually have a micro, what do you call it? Micro PCIe, and you can plug in wireless cards or any other kind of card you can get in micro PCIe on the bottom, or mini PCIe. I don't know what it's called, something like that. A lot of laptops have it. So basically, if you have a wireless card to your laptop, you can stick it into this. That makes it a little bit hard to sit on the table. You'll see it kind of flops around right there. So there's also right here a serial port. It looks like a headset port, but it's really for a serial connection, which is a little bit different. And then there's a couple other jumpers on it that are used for debugging. As I was holding that upside down, I could feel how warm it was getting. The light you see blinking is pin 13. So I have the blink sketch running right now. And then right here also is an SD card or micro SD card slot right here. So, you there, Bob?
Yep, I'm here.
I'm just getting a little echo or something. I thought you were asking a question. Sorry. So, overall, it's not a horrible board. It's a little bit hard to get used to, and I'm going to explain where that comes in. Is this board is actually running Linux. So it doesn't run the Arduino native bootloader like you think of when you talk about these small ones. So it takes about 40 seconds to boot, so a lot longer to get up and going than a typical Arduino. The other thing is you have 2 buttons. You have the reset button, which sends the shield to the reset and resets the sketch. But then you got a boot button right here. So you see right now I have the blink running. I'm going to go ahead and I am going to hit the reboot button like this. And you'll see that the blink stopped. And what you're going to find is the blink never starts back up again because the Galileo does not remember what sketch you have loaded into it. When it comes back on, there is no sketch loaded. So you have to re-upload your sketch. Now, there is a way around this, and I'm going to show that to you here in a second. But basically what it requires is a micro SD card in this slot. And it will then remember the sketch. You load basically the bootloader onto this, and then you load the sketch. Now, one thing that when it gets ready to boot, you'll see right here is a USB LED. So it's still not ready yet. And we're going to let it go just a little bit longer here. Let me see if the if it showed up here yet. No, it's still booting. So you can see how long it's taking just to boot the device itself. So the sketch, if you had a sketch in here in the micro SD, which I'm going to load one here and show you how that works, it's taking this long for the Arduino itself to come up.
So first you have to boot it up the OS, and then you can get to the Arduino part.
Right. So basically, it's running on top of a Linux kernel. Now it looks like, I'm going to guess that because it normally doesn't take this long, the reset didn't work. I've had this happen to me a couple of times where I've hit the reset or the reboot button and it doesn't boot. So I'm going to go ahead and I'm going to pull the power. And they're very funny about the power. They want you to put power in first, then Ethernet. So I guess it can be backfed by electricity or by the 5 volts on the USB, and they don't want that to happen. So I'm going to do that real quick. All right, we'll let it boot again here. So there, the USB is there. Let me see if I got the port available to me. I don't have the port yet, so it's not booted yet. And there's some other things that are somewhat insecure. I'm going to kind of walk through that and show you. There's no password on the Linux, so that's a little bit of an issue. And I'll show that.
Is it a custom version of Linux? Or
it is.
Okay.
It is. They have a different name for it. They've even taken things like the PS-AX that you would normally use to look at what's running. It's just PS. You can't add any additional options to it.
Okay.
So they definitely stripped it down. All right, now it's available. Okay, so now I can talk to it. All right, so what I'm going to do, as you see right now, there's no Blink running on it because it completely lost what it was doing. I'm going to go ahead and I'm going to upload Blink again. All right, it's uploading. It compiles and looks differently when it uploads. See, there you see Blink's running. Now what I'm going to do is I'm going to unplug it and plug it in my SD card and show you that by plugging in the SD card, it remembers the sketch. And I think this is where the 40 seconds comes in because it must be when it boots off of the card, it takes longer to load. You'll see actually the light blinking up there. There's a SD access light right there blinking. That's it reading the card. All right, let's see if I have. So not there yet. One of the cool things about it is you can actually access the Unix from inside the sketch. I'm actually going to show you how that works. That's how you get access to it via the network. So we'll show you how that works as well. But it's very interesting.
Yeah, that is interesting.
In fact, one of the things I was reading talks about using, it comes with Python on the card that you create. Okay, then my Blink's running. So there you see the sketch loaded without me having to upload the sketch to it. So yeah, the SD card from that point of view works good. Now I have a 32 gigabyte in here just because that's all I had. I took it out of my GoPro camera because I couldn't find another one laying around. But the maximum you can do is 32 gigabytes, so you can't go any larger. And I'm only using a fraction of it to get the boot. So what I want to do is I want to jump over to the computer. Actually, I'll show you the Blink. It's really the same code we use for Blink. It's the same code. It's exactly the same sketch as what we would normally use for Blink. Nothing special. Everything you do, including Ethernet, which is surprising to me, works exactly the same as it does on a regular Arduino. So they've converted all that stuff over. So let me go back here and get to the other sketch. So one of the things you can do, and here you see where I'm calling system right here, is when you call a system, you're calling the console. So what I'm going to do, first of all, is I'm going to do an ifconfig. If you're familiar with Unix, that outputs your interface IP addresses and things like that. So I'm going to do that first so I know how to connect to it. Actually, I better plug it in before I do that. Let me find a cable here real quick. All right, I got it plugged into Ethernet. So here's the other thing I found out is if you don't have it plugged into Ethernet when you turn it on, it won't get an IP address. So I just restarted it after I plugged it in. We can walk through this before I upload this. So basically what I'm going to do is I'm going to print out the Ethernet IP address that's assigned by my DHCP server. And this dev/ttygs0 is the same thing as writing to the serial port. So I'm basically going to tell the Unix partition, or the Unix operating system, to write to this dev, which will put it to my serial port. So I'm going to start my serial port and we'll show that. Then I'm going to tell it to start the telnet daemon. So I start telnet-d, and I tell it that I want to start up /bin/sh when I telnet to it. And then down here, I'm going to keep every 5 seconds just printing out the Ethernet address. So let's see if it's back ready for me. Okay, it is. So let me go ahead and I'm going to upload this sketch. All right, it's done uploading. Let's go look at the serial monitor.
Oh, the upload was quick too.
It was. So here's the IP address of the device, 10.232.1.138. So I'm going to open up a console, and I'm just going to do telnet, and then it's 10.232.1.138. And there I am at the root of the device. No login or anything required, which is a little bit scary. But if you look, you see I'm in the operating system. If I go into the sketch folder,
they definitely have trimmed down this version of Linux.
Oh, yes.
I bet they got rid of all of the security.
So there's the actual sketch that you would see if you looked at it on your machine. You know, if you looked at the actual ELF file, the compiled file. So that's stored in the sketch folder. If we go into the dev folder, there are, let's see, where's it at here? There's a directory just for all the different ports. You can actually go into the port. I thought it was called ports, but I don't see it. Oh, there's port. No, that's not it. You can set your ports in or out and all that from inside of here as well. Oh, wait, it's not in dev. That's where they reside, but it's not where it's configured. I'm trying to remember where it was. It's somewhere in this area. I found it earlier. When I was reading the online documentation about it, it told you where you can go. So you can actually set the pins on the Arduino from inside of Linux. From, you know, so you can write your own scripts in Linux to do that. You can call those then from inside of here. In fact, they're very tied into Python. They actually have routines that are called like p-write, p-read, that actually will execute Python scripts and will read data or set data based on what you want done in Python itself. So they have Python built into this. So you can see I'm now in Python right there.
Okay.
So you can call that from inside you can write all your hard stuff in Python in Linux and then call it from the Arduino. Oops. So that's how you get to the command prompt. Now you don't have to go to the command prompt. You can do it all using things like the system commands as well. So there is good documentation on how you can get in and use some of the advanced features of the device out there. It's very difficult to get your head wrapped around it at first. I spent quite a bit of time on it. In fact, the first one that I did, I got 2 of these when I got them. I thought I had broken it. It ended up being that when you do a typical Arduino, if you go in to the serial port, it's generally the TTY interface, but on this one, it's the CU interface. So I was using the wrong one. That's what the problem was with the first one. To do upgrades, and now what I found is you have to take out the micro SD card and then reboot it, power it off and power it back on again, and then you can come in and you go to help and you can do a firmware update. But if you're downloading the firmware onto the micro SD card, it doesn't really matter because it boots off of that instead of off of the internal. So if you're going to do it that way, don't waste your time in upgrading it. I will say if you're going to do anything serious with it, you probably need a micro SD card, and they're not that expensive. The 32 gig that I have in there is way overkill. In fact, if I go out here and I look at how much space is still available on it, I got close to 30 gigabytes, 30.8 gigabytes out of the 32, which isn't truly 32 probably. So there's plenty of extra space left on that. So it's pretty interesting. It's been a little bit of a battle trying to figure it out at first. I was thinking so much in the old Arduino way and not in the new Arduino way. So there's some pros and cons to it. I told Bob earlier today that's a little bit of a pain to deal with the way some of the things work. But I think if you get used to it, it ultimately will be okay. I'm not comfortable yet using it in anything long-term type of project. I've just had too many weird issues like hitting reboot doesn't reboot, things like that, that I'm not quite 100% trusting the device yet. So what do you think, Bob?
I think I need to go pick mine up.
Yeah.
I have one sitting at the I live within driving distance of a Mauser warehouse, so I have one sitting there at the will call desk waiting for me to drive over and pick up.
Yeah, now it comes with a power supply and everything. So the one thing it doesn't come with, which is a little bit frustrating, is the micro SD cable. I mean, the micro USB cable. I have some sitting around here, but somebody,
I've got some sitting around too.
Not everybody does. It depends. Sometimes your phone, they don't want to use their phone's cable for it. So it doesn't come with that, but it comes with the power supply, which is good. And it comes with every possible power adapter for every country in the world, I think, in this bag. So
okay.
I'm collecting those things. A lot of things seem to come with that same power adapter. It is a 9-volt power adapter too. It's not a 5-volt. So it will not run off a USB.
Okay.
So that's something
even though the CPU itself it's still a 5-volt system.
Actually, it's switchable. It can be a 5 or a 3-volt system, depending what you want it to be. There's there's jumpers on it right here that allow you to pick what you want, a 5 or a 3-volt system, and also what your HREF is. And there's also a jumper that allows you to pick which pins right over here. I don't know if you can see it right there. It allows you to pick which pins you want to be the serial communication pins for like the I2C stuff. So you can move those around as well.
Well, I like having the SD card on the board itself. That's one.
I actually like having the Ethernet there too, because I've had issue with Ethernet cards just like locking up on me at certain points. That's why I'm kind of want to put it to the test and see what I can do with it. It seems like if I stick to the Arduino branded Ethernet cards, I don't have the problem. But I've tried other brands and like it works for a day, and then it's something that's consistently running it just like locks up. And I can never figure out why. I never had that problem yet with the Arduino brand, so something's a little different. But so I'm kind of hoping that this, plus the fact that I can get into Unix and have it do a lot of the hard work without having to do it in the Arduino itself, using Python or shell script, is a big thing. In fact, the site that I found where I was trying to learn all this interaction between the Unix actually had you downloading websites in Python, and bringing them back and doing other things in Python just to get quick answers back.
Can you use other things besides Python?
Shell script, Bash. I believe it's Bash. I think.
Okay.
Here, I can tell you. No, it just says shell. It doesn't say which shell. /bin/sh. So yeah, I mean, it's shell script. Whatever you want, you can do with that.
Okay.
I'm sure you can probably load other things on there. Like I said, my card isn't very full at all, and I could probably put more things on there. I just don't know what it supports, what they've stripped out of it, and what it supports compiler-wise and things like that. In fact, I haven't tried, like, Yum is missing. Let me see if apt-get is there. Yeah, so all the things that make it easy to install packages is gone.
Okay.
So I'm going to keep looking. I'll keep playing with that part of it. I don't know what all you can and cannot do with it. It's definitely seems like it's quite a bit quicker as far as, getting things done. I haven't put a time test to it. Now, the other thing it has, which I don't have on this, is there's a jumper pin right here for a battery, and it will hold time if you touch a battery to it. So by default, there's no battery, so it will lose date and time. But you can, if you want it to hold date and time, you attach a battery to there, and it will hold your date and time as well, which is something that the other Arduinos don't even do at all.
Right. Yeah, you've got to have an external clock
right.
to do anything.
Right. So yeah, pretty interesting. I mean, it's I'm still holding judgment on, is it a recommended buy? I can't say that yet because I still have some fear around it because of some inconsistencies that I've experienced with it. But still something it's interesting to play with. I did build another shield today for one of my other switching products. I was going to put it to test with it maybe in the next couple of days. That built a smaller shield that's a breakout shield that I can try and see if it functions, how well it functions with that as well, just out of curiosity. All right.
All right. It's good.
Yep. So let's go ahead and hop over to your decade counter.
All right. Let me switch. So this is my decade counter, and this is actually this is a viewer question, and let me actually show you the schematic of what we're looking at here. And all we have is a switch, and essentially what a decade counter is it doesn't think, it doesn't do anything, it just as it receives a pulse, it goes from one count to the next and that's all it does. But it can be very useful. So this is the circuit, and the only thing I don't have on here is I do actually have an extra LED, and you can see it right here on the screen. I haven't done anything with it, and all it's there for is to show you when a pulse comes through. So we have voltage, we have ground, and then I've got the reset. I've got the reset and the clock inhibit low, and the reset, and they do just what their names imply. The reset will reset the whole thing. The clock inhibit will actually stop the reception of any pulses that happen to come in. So if that pin goes high, you can pulse the thing all at once and it's not going to count anymore. So, and I put this little switch on it so you can actually see that as I click it, it pulses, it receives a pulse, and it goes to the next counter. Very simple, very easy, very straightforward. Now you say, okay, well, how useful is this? Well, this is what we were talking about with the 555 episode, is that you can use this, a 555 timer, and build yourself a traffic light. And I didn't actually build the traffic light here, but I did make a schematic for it. So the top breadboard that we're looking at here, that's the design that I have. And then what this mess is right here is these are basically I've simulated a quad or logic chip, which just basically means if it receives, if any one of the 4 lines is high, then the output is high. And then on this side, on this chip, this is a 2 input or IC, and essentially that's a traffic light right there. So a 555, a decade counter, and a couple of these OR logic chips, and here you are, and you have a traffic light. And the only thing you have to kind of remember is that on the output, this blue line right here is going to the green. Well, if it's green on one light, it has to be red on the other light. And when you go to yellow on that light, it's still red on the other light. So at any given point, you have 4 states that these traffic lights can be in. So with just literally $5 worth of parts, you can have yourself a traffic light controller. It's that easy, it's that simple. And this decade counter it does, it just, when it receives a pulse, it moves to the next count. Now, one thing I did do, I started off with this being controlled by a 555 and then scrapped that and put the switch in because I wanted to be able to do it manually. And then I decided, no, I really do want to have it connected to something. So I've got my Leonardo over on the other side of the, you can just see part of it. And what we're going to do is we're going to unplug this, and of course it goes crazy because now it doesn't know what it's receiving. So this is the Leonardo, and right now we're pulsing it for 1 millisecond, and then we're waiting for 1 second to go to the next one. And we can change this to, what do you want to change it to?
200.
Want to be quick?
Yep.
It should go crazy when it uploads the sketch. And there you go. Each light stays on 200 milliseconds. So we could crank it up, we could set this at 50 milliseconds and it actually go faster than what the camera can read it. Or we can we can change it to whatever number we want. So
the decade counter you're using, is it 8 or 10?
This is a 10.
Okay.
This is a 4017. The actual model number is CD 4017B. And let me get I have the data sheet. Here's the data sheet for it. So, and I've got a 17, which is the 10, count, and then of course the 4022 is the 8 count. So, it's one of these. You know, it's kind of like the 555 or shift registers or logic chip. I mean, they're all nice little things to have in your bag of tricks to use. Um, and I got asked several questions about what is a decade counter and can we see one in action following that 555 episode. So, you know, this is straight out of a, you know, somebody asked what it was. So it's a nice little circuit that can be really useful in the right circumstance.
So with the example you gave for the stoplight, you're using ORs or ANDs or both? You're using ORs, right?
Using those are quad ORs.
Okay.
Now I do need to, let me get the circuit back up. I do need to warn. This diagram makes the assumption that when this goes high, or I'm sorry, when each one of these goes low, that it's not that the current is clamped off. In some of these decade counters, when they go low, they will tie the pin to ground, which means that in this circuit, right in this OR, you could actually create a short circuit because one of these input lines will be high, but the other three will be tied to ground. So you'll actually need diodes in here to prevent current flow going backwards back into the decade counter. Better decade counters will clamp it off so no current can flow in or out of the pin when it's not in use. Does that hopefully that makes sense?
Yeah, that makes sense. You don't want to backfeed power. That'd be bad.
Yes. So you know, so this design could change depending on the quality and the variation of the decade counter.
The fact that you use LEDs help prevent that in this case, though.
Say that. I'm sorry. Say
the
that
fact
again?
that you use LEDs help prevent that in this case.
That's if I had the because I used LEDs, there's no possibility of backflow. But if I stuck in these logic, an OR logic chip, I could still get backflow. I could still get a short.
Right.
So, but that is one little warning about, if somebody's going to build this circuit, they potentially could have to, would need diodes to prevent the backflow. Just depends on the quality of the decade counter.
All right.
So hopefully that answers the questions that came up before. And of course, if we have I thought about doing a demonstration of some basic logic chips, and if somebody's interested in that, we can do that.
I think we should go ahead and do that. Explain what an AND and an OR is, and demonstrate that. That'd be a good non-CPU based logic demonstration.
Yeah, and logic chips, they can be very useful, and and I'll go ahead and work up a demo on the basic ORs and ANDs and XORs, and that'll be a good episode.
Actually, that would be, and actually, maybe even good maybe to tie that. I can work on the side in the Arduino and how it's done in the Arduino as well.
Okay.
Because it's the same concept, just one's completely electronic and one of them is logic based.
That's right. They are.
All right. Well, we actually had a short show, 40 minutes. About.
Well, a lot of, good. Sometimes we go long, sometimes we're quick.
Yep.
It worked out okay.
Yep. Especially when we show up, don't have like birthdays to attend to.
That's right.
Yeah, I wouldn't have. My last show would have been 2 weeks ago if I had forgotten that.
Well,
so
you gotta take care of you must take care of the boss.
Yes, that is true. All right, so if you have ideas for future shows, definitely email us. I've seen a few emails flying around today with questions. I answered one of them earlier just before the show about an LCD display, so I need to get back and I think I need to go out and do an actual schematic for that episode. I think it was episode 5 and 10. So, and then Jim had the question about the TV out circuit, so that was kind of interesting. That'd be a fun one to do.
Yeah, I actually was digging through my box of parts and couldn't find a spare RCA cable.
Oh,
so
really? Wow.
I guess I was really good at cleaning up my box of parts the last time I went through it. So
yeah, I got a box full of those kind of cables back here that probably never get used.
Well, I'm sure I've got one around here somewhere. I just have to find it and cut it up. So
yeah, so if
TV out from an Arduino is kind of interesting.
Yep, absolutely. I think that'd be kind of cool. So yeah, any kind of ideas for other shows, just let us know. We definitely would like to get, the kind of things that you want to see us do. We'd like to have your input on that so we can kind of head that direction. We still have a list of things on our own that we want to do, but it's just picking things every week that we want to do. So we haven't even discussed next week yet, I don't believe. Do we?
No, not yet.
All right, we'll have to go back to our list and see.
Aren't we? We plan ahead, don't we?
Yeah, this last couple of months has been really crazy for me. Yeah, so it's starting to slow down a little bit, but it's probably a couple more weeks before it gets back to normal for me. So Jim says he has some ideas. Send them over, Jim. Love to see them. Get your ideas, and it doesn't have to be on an Arduino. I know Jim's an Arduino guy, but if you have things you'd like to talk about on other platforms, I have a BeagleBone now I've been playing with, a new dude I've been playing with, and now I got the Intel Galileo.
And of course, it doesn't even have to be one of those.
Nope.
We've done, shift registers, timers,
right? Anything basically electronics.
Yeah, anything electronic, from the most basic to current high-tech fun, like the BeagleBone and the Udo, and yeah, I'm game for all of it.
Yeah, me too. I actually have some other things I've been playing with in my spare time for things around the house, so I'm recording them as I go along. So maybe I'll make them into segments at some point. I have a garage door opener thing for the garage, and also monitors the freezer, because we've had some power problems out there with I guess in our state we have to have anything outside like that, and it's considered outside of the garage, has to have the ground fault, the GFC plugs. For some reason we keep tripping them. So Jim says a state machine.
We can talk about that too.
Yep, it's another good one. All right, well, everybody go, and we'll see everybody next Monday, which is, what is that, the 20-something, 24th?
24th.
So, and no clue what we're going to do yet. We'll surprise you next week.
Well, we'll come up with something.
Yep, we'll definitely. We have a long list of things in Google Docs that we haven't done yet, so we'll pick something out of there, or unless we get an idea from somebody else. At some point, I think when you get back, we need to revisit the LCD episode as well, because we're getting a lot of questions about that here recently.
Yeah, we have gotten quite a few questions.
And I think it's just confusing because everybody has a different address than other manufacturers and things like that. There's not like a standard, unless you're using parallel, which then there is a standard.
Yeah, too many variations, too many manufacturers. Yeah, it does get difficult. So
right. So we'll go back and we'll visit that. That was the question I had today about the same thing. So, all right, everybody. We'll see everybody next week.
All right. Good night.
All right. Night, everybody. For show notes for this show, contacts, and more, go to the TechZen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.